Good evening, everyone. I hope you all had a great weekend. I just wanted to quickly show you a demonstration just to show the relationship between the different interest rates, the different rates in general that you guys will be using uh, throughout FinMath. And this will just make it easier for you guys to be able to understand the relationship between the different rates and to be able to interchange between them should you need to change between them very quickly. Okay, there's also kind of just to serve as an intro to Excel. I know some of you guys aren't familiar with Excel, at least in an actuarial context. So this will be able to help you guys kind of get to grips with it. I don't know, get to know it a little bit. Please know that Excel has a function now, so where it has Copilot in the app. I think it's just in the corner there, where it has Copilot in the program for Excel. So if you need help with the shortcuts or automating something, you can ask the Copilot what you need help with, and it will be able to assist you. But for some of the more, so I won't be going over some of the more basic functions, but for some functions that I do find useful for this course and that I do think need a bit of going over, I will kind of stop to highlight and emphasize through the video. Okay, let's start. So we can start off with an interest rate, an effective interest rate. So just kind of a reminder, an effective interest rate is the total interest paid once per measurement period. So if your measurement period is a year, you have an annual effective interest rate. If it's 2 years, you have a biannual, I think, effective interest rate. But it'll be paid at the end of that period. So an annual effective rate, the total interest earned in that period will be paid at the end of the year. For a 2-year effective rate, it'll be paid at the end of 2 years. If it's a 6-month effective rate, it'll be paid at the end of 6 months. So an interest rate in general is in arrears. So we're going to start off with kind of an interest rate of 10%, and then we'll take it from there. An effective discount rate, for practicality reasons and to make it easier to understand, I'm going to be using our effective period as months. So no, as years. So the effective interest rate will be an annual effective rate. So the 10% will be received at the end of the year, and an effective discount rate is the total interest earned in the effective measurement period, but it's earned at the beginning of the year. So you can get the discount rate by present valuing the interest rate, because it is just the interest, but it's earned at the beginning of the year. So since the interest rate is earned at the end of the year and the discount rate is earned at the beginning of the year, you can present value the interest rate to times 0 at the beginning of the year to get the discount rate. So we raise this to the power of -1, and there you go. You present valued the interest rate, saying 10% times the discounting factor, v to the power of 1, to take it back to times 0, and now you have your annual discount rate at 9%. Now this is all good and well. It's easy to understand when you're talking about like years and the effective period. Our effective period being a year, the interest rate is 10% earned at the end of the year. The discount rate is 9%, is the interest rate, but it's earned at the beginning of the year, so its equivalent will be 9.09%. Well, what if you don't want to work in the effective yearly period? You want to work in finer periods within that year, like weeks, days, months, whatever. Well, you can divide your main interval, which will be from 0 to 1, because the effective interval will go from 0 to 1. So 0 to 1 years. We can divide that 1 year into finer sub-intervals. For example, we can divide a year into 12 sub-intervals, and each sub-interval will represent a month. So in 1 year, we have 12 months. So in one effective period, we have 12 finer periods, which we'll call months. So that's what our P is. And from this, we can get nominal rates, convertible Peathly. In this case, nominal rates convertible monthly. And I'm sure you know the equation for this. It's 12 times 1 plus the interest rate to the power of 1 over the number of subintervals minus 1. So this is the nominal rate, the nominal interest rate convertible monthly. And we can do the same to get our nominal discount rate convertible monthly. So this will be 12 times, forgot my equals, 12 times 1 minus 1 plus the interest rate to the power of minus 1 over the number of subintervals again. And that's your nominal discount rates. Before I explain the nominal discount rate and interest rates convertible piecely, I find it easier after we've calculated the effective nominal rates. So that means IP over P. IP over P will be equal to the nominal interest rate divided by the number of subintervals. So this is the IP over P is the effective interest rate per subinterval. Our subintervals, we have 12 subintervals, so we have months. So this is the effective interest rate per month. The reason why it's like a nominal rate, IP over P, is because our main measurement period, our main effective period is a year. This is why we have I here. And so when we divide that year into finer periods, everything else is nominal. So we'll have IP. And so to get the effective rate for those subintervals, we divide IP by the number of subintervals to get 0.797. And the same goes for dP over P. This is the effective discount rate per subinterval. So this is the effective monthly discount rate. And we do the same thing. We divide the nominal discount rate convertible monthly by the number of subintervals, or by the number of months in a year, which is 12. Like that. So this nominal interest rate convertible yearly is just the sum of all the effective monthly interest rate. No, I didn't say that right. This interest rate, nominal interest rate convertible monthly is the sum of all the effective monthly rates. And this discount rate convertible monthly is the sum of all the effective monthly discount rates. Moving over to the effective monthly rates. The effective monthly interest rate is just the interest rate earned at the end, is the amount of interest earned at the end of each month. So it's effective to that month. And remember that an effective interest rate is earned at the end of the measurement period. We change the measurement period from a year to a month. So the effective interest rate, or the effective monthly rate, is the interest earned at the end of each month. So the interest earned at the end of each of the year is 10%. The interest earned at the end of each month is 0.79%. And if we add all the effective interest earned in each month, if we just add them all, we have 9.569. The effective monthly discount rate is the discount rate earned at the start of each month. Because we've divided the year into 12 months, now the effective monthly discount rate is the discount rate earned at the start of each month. And if we add all of these up, let me show you. If you add all the discount rates up, so there's 12 months, so we'll have 12 effective discount rates, and they'll all be equal to this. If we add all of them up, in other words, 12 times this, you'll get the effective discount rate. 12 times, not the effective, the nominal discount rate convertible monthly, and the same goes for the interest rate. So that's the relationship there. And this is why the nominal rate convertible piecely is kind of useless, because you can't really use this to present value anything. You first have to make it an effective rate either by transforming it into I or D, or turning it into IP over P or DP over P. You can't use it as is. Whereas this, because it's effective for that month and earned at the end of that month, you can use this as an effective monthly rate when you're dealing with months. You can use this as an effective monthly discount rate when you're dealing with months. This you can't use because it's not effective to the month. It's just all the monthly rates added up. Okay, I hope that makes sense. I know that was a bit of a mouthful. It was a bit of a mouthful, but yeah, I hope you guys understood that. Just gonna make this pretty now. So just to go over this one more time, we have an effective interest rate, 10%. The discount, it's the interest earned at the end of the year. The discount rate, the effective discount rate, is the interest, but it's received at the start of the year. So you can get it by present valuing the interest rate. And if you want to work with finer intervals, finer sub-intervals within our main interval, you can divide it into however many P sub-intervals you want. In this case, we want months, so we divide P as, we use P as 12. If we wanted weeks, we'd say 52, and our rates would change. If we wanted days, we'd say 365, and our rates would change. But we're going to work with months because we like months. Months are easy. Moving over to the effective monthly rates. So an effective monthly interest rate, remember, an interest rate, an effective rate, is earned at the end of the measurement period. Since we changed our measurement period from a year to 12 sub-intervals, which are months, this is the effective monthly rate. So it's the effective interest rate earned at the end of each month, which will be 0.79, and the effective discount rate will be earned, monthly discount rate will be earned at the start of each month. So this will be 0.7911. And the nominal rates, the nominal interest rate convertible monthly, is just the sum of all the effective discount rates and the nominal of all the effective monthly rates, and the nominal discount rate convertible monthly will be the sum of all the effective monthly discount rates. Okay, easy stuff. So now we move on with our illustration. Since we divided our year into 12 sub-intervals, our time will start from 0, and then it'll go to 1 over 12. I don't know what that is equal to. 1 over 12. And then we'll add 1 over 12 again. Just fix this cell. Yeah. Till it gets to 1. Okay. This is a bit ugly. If we had made it, divided our thing into 10, it would have made it look a bit better, but yeah, whatever. We'll work with this, I guess. So this is each 12th of the year. This is times 0, the first month, second month, third month, fourth month, fifth month, sixth month, seventh month. 6th month is the halfway point, and then you get to your 12th month, which is a year. What exactly are we saying with this rate? This is like a time. This is the Excel equivalent of a timeline, by the way, if you haven't noticed. So yeah. Now let's look at IP over P. We said this is the effective monthly rate earned at the end of each month. So times 0 is the beginning of the first month. Here is the end of the first month. So at the end of the first month, you'll earn this monthly effective rate. And I'll fix that here. By the way, if you want to fix a cell in Excel for your formula, just press FN. How do you fix a cell? You reference your cell that you want to fix, for example here, and then you press FN F4 on your laptop. You press FN and then F4, and then it'll fix it. Or alternatively, you can just put these dollar signs behind the cell, behind the row reference and the cell the behind the column reference and the cell reference manually, and it'll fix it. But that's very tedious. It gets very tedious very quickly. And then I'll just drop down. If you want to drop down your formula, you can go to the corner here and then wait until this white arrow thing turns into this smaller black arrow thing, and then just double click on that. So at the end of the first month, we earn the interest, the effective monthly interest, and end of the second month, third month, fourth month, until the 12th month. And for the discount rate, the monthly effective discount rate, you earn it at the start of each month. So we'll have these at the start of each month. But be careful, because since it's at the start of each month, you won't earn anything at the end of the last month. So like this, we have 12 of them here from the beginning. This is like this in advance. Yeah, this is like this. This is exactly like this in advance. So that's your monthly effective interest rate, and this is your monthly effective discount rate. And like we said before, you can get the nominal interest rate convertible monthly by just summing your monthly effective interest rates. That's a function that adds kind of elements of cells together. That kind of adds cells together. The function is called sum. You just equal sum, and then it'll pop up, and then you can insert what you want to add. Just show you again with the discount rate, sum, and then I want to add these. So you can see that if we add these, if we add our monthly effective interest rate, we get the nominal interest rate convertible monthly. If we add the monthly effective discount rate, we get the discount rates convertible monthly. Cool. All nice and easy. Now the more tricky relationship. I'm going to add something called a discount factor. I'm going to create a row for a column for something called a discount factor. Discount factors, and another one for accumulation factors. Now, I'm sure you're familiar with your discount factor being equals to 1 plus the interest rate, which I'm going to fix fn4 to the power of minus wherever you're discounting from. So if you're discounting from time 1, it's going to be minus 1, from time 2 minus 2. Here we're going to be discounting from each one of these cells. So I'm going to start the discount factor for time 0 is going to discount from time 0. So it's going to be this raised, the interest rate that raised to the power of 0, and that'll be the same for each of this. Discounting from time 1 will be 1 plus the interest rate to the power of minus 1. Cool. The accumulation factors, again, I'm sure you're familiar with the fact that your accumulation factor is 1 plus the interest rate, which I'm going to fix to the positive power of where you're discounting to. So here we're from time 0 and we're going to be discounting from time 1. So it needs to travel a distance of, this is going to get tricky, f4 minus f2. I'm going to put brackets behind there. So I say f4, f14 minus f2 because the amount of time with which you accumulate whatever you're accumulating forward is the difference between the time that you're accumulating to and the time that you're accumulating for. For example, if you want to accumulate something from time 2 to time 5, the accumulation factor will be raised to the power of is going to be 1 plus I to the power of 5 minus 2, which will be 1 plus I to the power of 3. Accumulating from time 2 to time 5 is going to be 5 minus to the power of 5 minus 2, which is to the power of 3. That's exactly what I'm doing here. And then you'll get all of your accumulation factors. This is, I'm gonna fix F14 here because I don't want the time. I'm accumulating them all to time 1 to the same time, so I'm gonna fix time 1. I don't want it to change, so they're all going to time 1. Yeah, that should fix things, because now if you're at time 1 already, you're going to, and you want to accumulate to time 1, effectively accumulation factor is just 1. You're just going to be multiplying whatever you're accumulating by 1. Why do I have discount factors and accumulation factors? Well, because the interest rate is the total interest earned at the end of the measurement period. This effectively means that if we take the interest rate earned at the end of each month and we accumulate all of them to the end of the year and sum them all up, we should be able to get back to this. I'm going to repeat that because it's quite a mouthful. The reason we have accumulation factors is because since the interest rate is the total interest earned at the end of each measurement period, so the interest rate, the annual effective rate is the interest rate earned at the end of each month. The annual effective interest rate is the total interest rate earned at the end of the year. Theoretically, we should be able to get to the annual effective rate by saying the amount of interest you earn at the end of each month, and we accumulate each of those interests to the end of the year and then add them up. This is how we're going to do that. So we're going to have IP over P times accumulation factors. We're just gonna do this, multiply the monthly effective interest times the relevant accumulation factors, and we're gonna do that for all of them. There you go. And then we should be able to, if we did this correctly, recover the interest rate by summing over each one of these. There you go. We got back the interest rate using the effective monthly rates. We can do a similar thing for the discount rates. Now, since the discount rate is the total interest rate earned at the beginning of the period, it means that we can discount each of the monthly discount rates that we get at the beginning of each month. We can discount them back to time 0 and then add them up to recover the discount rate. So basically, more or less the opposite of what we did here. I'm going to say DP. You better get DP for this course. Times the discount rate is going to be each monthly effective discount rate times the discount factor. And we're going to do that for each of these. And we should be able to recover D by taking the sum of these. There you go again. We're able to recover D. So since the monthly effective rate is the monthly effective discount rate is the amount of interest you earn at the beginning of each month, we can get the annual effective discount rate by taking the amount you earn at the beginning of each month, discounting it all back to the beginning of the year, and then adding all those small bits up. You should get D. For the effective interest rate, it's the amount of interest you get, the effective monthly rates you get, the effective monthly interest rate is the amount of interest you get at the end of each month, and you should be able to get back to the effective annual rate by accumulating these all to the end of the year and summing them all up. You can add nice borders, a nice border to all of these. Yeah, just make it a bit neater. And there is your discount rate, your interest rate, and your interest and discount rates convertible monthly. Now, what about delta? delta. Delta is your force of interest, by the way, is equal to 1 plus the natural logarithm 1 plus the interest rate. There's a natural logarithm function of x on Excel. You just press equal to ln and it'll give you that function, and then you just put whatever parameters you want on the inside. Okay, cool. So how do we get delta from all of these? Basically, your delta, because you know it as the limit as p goes to infinity of IP, effectively. Let me just make this into a percentage. Delta is the limit as p goes to infinity of IP. Look, if you look at of IP, which is equal to the limit of as p goes to infinity of dp. If you look at IP, the nominal rate convertible monthly, the nominal interest rate, it's 9.569%. If you look at DP, it's 9.493%. And if you look at our delta, it's 9.53%. So it's in between these two. This one, as the number of sub-intervals increases, this one becomes lower and lower and lower. And as the number of sub-intervals here increases, the discount rate convertible monthly increases, and they converge towards the middle value, which will be delta here. So right now they're both a bit far off, not far off, just slightly off the delta, but as p goes to infinity they'll both approach delta. I have a separate sheet where I approximated the delta here, where the delta is the force of interest is 8.618%, and I divided my sub-intervals into p equals 100. I just changed that here. I divided my sub-intervals, I divided my main interval, my year, into 100 sub-intervals, whatever that is. It's not months or weeks. I don't know what 100 sub-intervals in a year would be. But I divided my year into 100 sub-intervals and did all the same calculations. Of course, now everything is times 100, but did all the same calculations. And because there were more sub-intervals, the delta is more accurate here. As you can see, I calculated my delta the same way I calculated the nominal rate convertible Peatley, by just summing all of this up. And I did it both ways by summing these ones up. And as you can see, they're approaching this 8.618. This one is very close now. It's at 8.62. This one is at 8.614. The more sub-intervals I would have, the closer that they get. You can see that this one is tending towards 0.618. It's going down. This one is going up towards 0.618. So as the number of sub-intervals increases, the deltas, the nominal rates convertible Peatley tend towards delta. Okay, that was quite a mouthful. I hope this helps you guys. I have 3 separate sheets here. One for 100 sub-intervals, one for also 100 sub-intervals, and then this one that we're doing now. I'll send this to you guys, but just make sure that you kind of go over this, create an Excel sheet of yourself to kind of understand the interactions between these different rates, because it is important for you to be able to interchange between them seamlessly. And not only that, for you to fully understand them, because you need to fully understand them for you to be able to change between them and know what each one is useful for. And also just to get introduced to Excel, just to get to know Excel a bit more. So yeah, I really hope this helps. If there's anything that confused you guys, please just shoot a message on the group and me or Chezo will answer your questions. And yeah, have a great evening and have a great week. Bye.